Hello, good day everyone. This is Ismael and I will be discussing data flow diagram. So this is the continuation of the topics under data and processing model. So here is the topic outline of our discussion. So number 1, what is data flow diagram? Number 2, data flow diagram definitions and symbols. Then number 3, data flow diagram diagramming rules. Then number 4, guidelines for drawing data flow diagrams. Then number 5, creating a set of data flow diagram. So okay, let's begin. So what is a data flow diagram? So a data flow diagram is a graphic that illustrates the movement of data between external entities and the processes and data stores within a system. A data flow diagram shows how data moves through an information system but does not show program logic or processing steps. So a set of data flow diagrams provides a logical model that shows what the system does, not how it does. So a data flow diagrams are versatile diagramming tools. So with only 4 symbols, data flow diagram can represent both physical and logical information systems. So data flow diagram uses 4 basic symbols that represent process, data flows, and data store and entities. Then let's move to the different symbols and definitions of a data flow diagram. So we have 2 data flow diagram symbol sets, the Gain and Sarson and the Jordan symbols. So in this discussion, we will be using the Gain and Sarson symbols. So the first data flow diagram symbols is the data flow. So a data flow is a data that are in motion and moving as unit from one place in a system to another. So a data flow can be composed of many individual pieces of data that are generated at the same time and that flow together to common destinations. So a data flow is depicted as an arrow, as you can see here in this symbol. So the arrow is labeled with meaningful name for the data in motion. So the data flow name appears above or below or alongside the line. So a data flow name consists of a singular noun and an adjective if needed. So examples of data flow names are deposit, invoice payment, student grade, order, and commission, etc. So a data flow must have a process symbol on at least one end. So here's an example of a correct combination of data flow and a process symbols. Then we have also data flow and process combination that we must avoid. We have here 3 examples of data flow and process combinations that we must avoid. First is the spontaneous generation. So as you can see here in this example, so the apply insurance premium process for an instance produces output but has no input data flow. Because it has no input, the process is called a spontaneous generation process. Then next is the black hole. So the calculate gross pay process is called a black hole process, which is process that has input only but produces no output. So as you can see here in this example, there are only input data flows, no output data flows. Then the next one is the gray hole. A gray hole is a process that has at least one input and one output, but the input obviously is insufficient to generate the output shown. So you can see here in this example, the process has a input data flow which is named date of birth, and the output is final grade. So obviously this data flow diagram is not possible because the input is date of birth and the process is how to calculate grade, then the output data flow is final grade. So this example is called a gray hole. So that are the three examples of a data flow that we must avoid when we are drawing our data flow diagram. So as you can see, spontaneous generation and black hole and gray hole are impossible logically in a data flow diagram because a process must act on input shown by an incoming data flow and produce its output represented by an outgoing data flow. So let's move to data store. So another symbol of data flow diagram is the data store. So a data store is a data at rest. A data store may represent one of many different physical locations for data, so including a file folder or one or more computer-based file. So a data store is used in a data flow diagram to represent data that the system stores, because one or more processes needs to use the data at a later time. So this symbol is the storage of your information system. Then the symbol for a data store is a rectangle with a right vertical line missing. As you can see here in this example, there is no right vertical line here. So the name of the data store appears between the lines and identifies the data it contains. So a data store name is a plural name consisting of a noun and adjectives if needed. So example of the data store names are students, account receivable, products, daily payments, purchase order, outstanding checks, and employees. So the physical characteristic of a data store are not important because we are concerned only with the logical model, and also the length of time that data is stored is not also important. So what is important is that a process needs access to the data at some later time. So that's the use of the data store in your information system. Then we have here also some example of correct uses of data store symbol in a data flow diagram. So here, as you can see, there's a process post payment. Then after the process, there is an outgoing data flow, customer payment to the data storage, then another data flow which named daily payment to prepare deposit process. So this is an example of a data store symbol in a data flow diagram. Later on, we will discuss the rules of data flow diagram. Then we have here an incorrect example of uses of data store symbol. So two data store cannot be connected by a data flow without an intervening process. So here is the example. This data store, we should not use this data store and data flow in our diagram. No data store to data store. So it should have a process under your data flow before going to data store. Then let's move to process symbol. So a process is the work or action performed on data so that they are transformed, stored, or distributed. So the symbol for process is a rectangle with rounded corners. So this is the symbol of process. The process name identifies a specific function and consists of a verb followed by a singular noun. So this is an example of a process symbol. You have here a verb and a singular noun. Then a process symbol can be referred to us as a black box because the inputs, outputs, and general functions of the process are known, but the underlying details and logic of the process are hidden. So it is called a black box. Then let's move to the next symbols of data flow diagram, the entity or the source or sink symbols. So a source or sink is the origin or the destination of the data. So source or sinks are sometimes referred to us as external entities because they are outside the system. So a rectangular or a square is used for source or sink, and its name states what the external agent. For example, this one, your source is the customer, or it can be the sink. So data flow diagram entities are also called terminators because they are data origins or final destinations. System analysts call an entity that supplies data to the system a source. Then an entity that receives data from the system is called a sink. So an entity name is the singular form of a department, or it can be an outside organization or other information system or a person. So let us say here your entity is the bank. So this is an example of your entity symbol. So an external entity can be a source or a sink or both. So but each entity must be connected to a process by a data flow. So here is an example of a process and entity data flow. So a source or sink might consist of the following: another organization or organizational unit that sends data to or receive information from the system you are analyzing. And also it can be a person inside or outside the business unit supported by the system you are analyzing and who interacts with the system. Then next is it might be another information system with which the system you are analyzing exchanges information. Many times we students learning how to use data flow diagram become confused about whether a person or activity is a source or a sink or a process within a system, especially when a system data flows occur across or their departmental boundaries. So in such case, some processing occurs in one office and the processed data are moved to another office where additional processing occurs. So this is an example of a common mistakes of students who are still learning in creating data flow like me. So they make another entity to to entity data flow. So this is earlier we discussed that we should avoid this one, the entity to entity data flow diagram. So if you encounter such kind data flow analysis in your system, which you need another process, or the processing data in the other office should represent the second office, you should make another process on your data flow diagram. So in this example, the data flow diagram, it has three processes. So we add another process which is named update customer master. So a process to entity symbol, not this one, not to entity symbols. Should avoid this one. But however, if processing that occurs in the other office takes place outside the system you are working, then it should be a source or sink on your data flow diagram. So since the process is inside your system, you should put a process symbol here. So okay, then here are some examples of correct uses of external entities in a data flow diagrams, and also we have here an incorrect examples uses of external entities. So an external entity must be connected by a data flow to a process, so not directly to data store or another external entity. So this one, should avoid this one, like what we did here. Then next we move to the next topic, which is data flow diagramming rules. So first rule under process, letter A, no process can have only outputs. It is making data from nothing. So if an object has only outputs, then it must be a source. Then letter B, no process can have only inputs. If an object has only outputs, inputs, then it must be a sink. So here is an example of incorrect and correct uses of process. So as you can see here, there is an incoming data flow, then an outgoing data flow. So should avoid this one. So as you can see, there is no input data flow here. There should be an input data flow. Then in letter B, as you can see, there is no output here. There is no output. It's all input data flow. So here is the correct example of a process and data flow. Then the letter C rule, a process has a verb phrase level. So that's the three rules under process. Then let's move to data store. So the letter D rules under data store, data cannot move directly from one data store to another data store. Data must be moved by a process. Then also, as you can see here, the incorrect, so it only uses to data store, a data store to data store. So this should be the correct one. You should put a process symbol before going to another data store. Then the letter A under data store, data cannot move directly from an outside source to a data store. So data must be moved by a process that receives data from the source and places the data into the data store. So here's an example of an incorrect uses of data store. So he uses entity here and just directly use data store. Of course, you need to process your data before it go to your data store. So this is the correct one. This is the correct uses of entity, process, and to data store. So before going to data store, it should be processed. Then letter F under data store. Also, data cannot move directly to an outside sink from a data store. Data must be moved by a process. So again, this is an incorrect data store to external entity or your outside sink. It should be moved by your process. So your data store must be connected to a process symbol before going to your entities. Then letter G, a data store has a noun phrase level. Then let's move to the source or sink rules. Letter H, data cannot move directly from a source to a sink. They must be moved by a process if data are of any concern to our system. So this is an incorrect one. So earlier we have already tackled this one about entity to entity. So this is correct. This is incorrect example of a entity to entity. Of course, your entity must first go to a process before going to your sink. So here's the source. You have your source here. Then, of course, it will be processed first. Then it will go to your destination, your sink. So that's rules under source and sink. So a source or sink must be moved by a process. So then we have data flow rules. So letter J, a data flow has only one direction of flow between symbols. So it may flow in both directions between a process and a data store to show a read before an update. So the letter is usually indicated, however, by the two separate arrows because the read and update usually happens at different times. So here's an example of incorrect uses of data flow symbol. So if your information system has a update process, you should use to separate data flow, not this one. So again, the data flow tree. Then if the data is being updated, then it will move back to your process. Then we'll use another data flow symbol here. Then letter K, a fork in a data flow means that exactly the same data go from a common location to two or more different processes, data stores, or sources or sinks. So here, as you can see, same data flow name because it's just the same process. It's the same data. So you don't need to name another data flow name. Maybe we can understand this if we have an actual making of a data flow diagram. If we are creating information system. So here are some examples of correct and incorrect uses of data flows. So a process to process, so it's correct. So a process to external entity, so it's correct. So vice versa. So a process to data store. Then we have the incorrect, that we must avoid. The external entity to an external entity, an external entity to a data store. Then we have data store to data store. And let's move to the next topic, the guidelines for drawing data flow diagram. So first, draw the context diagram so it fits on one page. Then a second one, use the name of the information system as the process name in the context diagram. Then use unique names within its set of symbols. Then next one, do not cross the lines. So one way to achieve that goal is to restrict the number symbols in any data flow diagram. So on lower level diagram, in your already creating your lower level diagram with multiple processes, you should make sure that you're only using your process will not be more than 9 process symbols if you are creating your lower level diagram, because if you have more than 9 processes, it means that your diagram is too complex and that you should reconsider your analysis. Then next is to provide a unique name and a reference number for each process. Then obtain as much user input and feedback as possible. So your main objective is to ensure that the model is accurate, so easy to understand and meet the needs of each user. So here's an example of a context diagram, so here is another guideline that we discussed, using unique reference number for each process. So the context diagram has only one process, so you should put 0 here for this is your process number 0. So that means that is the context diagram. So then then use your information system name. So this context diagram is for a grading system, so that's why he uses the grading system process name. And the process 0 and has 3 entities: the student record system, student, then the instructor, and have a 1, 2, 3, 4, 5, 6 data flows. Then let's move the last topic, which is creating a set of data flow diagrams. So here are the steps in creating a set of data flow diagram. So first step is to draw a context diagram. So this is the first step in constructing a set of data flow diagram, is to draw a context diagram. So a context diagram is a top level view of an information system that shows the system boundaries and scope. So in this example, these are the boundaries: the sales rep, bank, accounting, warehouse, and of course the source, the customer. So to draw a context diagram, you start by placing a single process here, a single process symbol in the center of the page. So the symbol represents the entire information system, and you identified it as process 0. So then you place the system entities. Here, this is your system entities around the perimeter of the page, and use data flows that connect the entities to the central processes. As you can see, there is no data store in your context diagram because they are contained within the system and remain hidden until more detailed diagrams are created. So here, then step number 2 is to draw a diagram 0 for data flow diagram. So in the previous step, we learned that the context diagram provides the most general view of an information system and contains a single process symbol. So as you can see here in your diagram 0, we have already 3 processes, and we have now data store here. We have one data store, but same entities, same 5 entities. So you create a data flow diagram, zooms in on the system and shows major internal processes, data flows and data store. So when you expand the context diagram into data flow diagram 0, you must retain all the connection that data flow into and out of the process. As you can see here, same entities are used. Then the last step is to draw the lower level diagram. So this is the set of the lower level diagram. This is based on the order system. So to create a lower level diagram, you must use leveling and balancing techniques. So what is leveling techniques? Leveling is the process of drawing a series of increasingly detailed diagrams until all functional primitives are identified. So this functional primitive, this is your the lowest level data flow diagram. So if you have already expanded your processes, so this is your last diagram, the primitive, functional primitive. Then also leveling also is called exploding, partitioning, or decomposing. So here, and balancing is maintains consistency among set of data flow diagrams by ensuring that the input and output data flows align properly. So here is an example of diagram 0 in the left side, and here is the diagram 1, which means as you can see here, the process is numbered 1.1, 1.2, 1.3. This means that he expanded the process number 1, which named here in your diagram 0 field order. So this is the more detailed diagram under field order. So on the guidelines, we should use unique numbers under process symbols. So if you want to explode or have a more detailed processes under field order or your process 1, you should use 1.1, 1.2, 1.3, and so on until you reach your primitive diagram. So as you can see here, you exploded the process 1, which is field order, and he has now 3 processes, but the entity is just the same, the warehouse. So that is balancing. You should not change your entity in your diagram. So as you can see, all the processes are numbered using decimal notation consisting of the parent reference number. So here is your parent reference number. So for example, if you want to expand this 1.1 verified order process, you will use another number. You will add 1.1, 1.1.1, 1.1.2, and so on. So that's it. That will end my discussion about data flow diagram under data and processing model. So thank you for listening, and God bless.